Good morning. This recording is for pre-algebra video lecture, chapter 10, lesson 7, volume of prisms and cylinders. All right, I promise this will be so much less painful than surface area. Surface area is like a pain and volume is so much easier. Because really all you have to do is find the area of the base and then multiply by the height of whatever's going on. The job, though, that you have is that you actually need to figure out what the base is. When you're dealing with rectangular prisms or square prisms, it's a little hard to figure out what the base is, because really there's a bunch of different places the bases could be, but you are looking for basically where you have two of something, because when you have cylinders and prisms, which later on in math you're going to call them the exact same thing, you have two bases and they are the same shape and they are exactly the same. But again, when you have a square or rectangular prism slash cylinder, you have a lot of two of the same shape, so it's a little harder to figure out. But as long as you keep your dimensions straight in your brain, you should be able to figure out, or at least use something that would work as a base well for a rectangular prism or a square prism. Okay, so back to volume. The volume of a three-dimensional figure is the number of cubic units needed to fill it. A cubic unit is the space occupied by a cube with edges 1 unit long. So it could be 1 centimeter by 1 centimeter by 1 centimeter, a cube, or 1 foot by 1 foot by 1 foot, or even if you're like measuring large vast amount of water, it would be like mile by mile by mile. So huge units can be whatever you need them to be, and sometimes they're undefined. If you just have like a number by an edge, we just say that they're units. All right, so if it doesn't say like 4 centimeters or 4 miles or 4 meters, it just has a 4 there. It means it's 4 units. So you can actually still like do your stuff. So like if there's actually no specific units and it's just like 4 by 3 by 5, you could, or excuse me, that's not where the 5 would be. The 5 would be right there. You would say that this would be, the volume of this would be 4 times 3 times 5 units cubed. So it'd be 12 times 5, which is 60. So 60 units cubed. All right, so just realize that if they don't have like centimeters, feet, meters, blah, 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 and they just give you numbers, then you can still say it's 60 units cubed because you don't actually know what the units are. So the word units or unit is like a catch-all. Okay, so back to volume. We have a three-dimensional shape, like this one right here, all right? And I want to figure out the volume. So I'm going to figure out how many of these little tiny cubes fit in them. So I need to think of volume kind of like in layers, where I have the area of a bottom layer, and that's just the area of the base. And then what I'm going to do is I'm going to take all of that, and I am going to multiply the area of one layer by the number of layers I need to get to the top of my space figure. Okay, so that's what I'm going to do. So think of the volume as the cubic layers or area that makes up the base multiplied by the height of the space figure. So if you figure out the area of the base, in this case it would be 8 times 5, which is 40, and then multiplied that by the number of layers I need, and down here you can see the number of layers. 1, 2, 3, 4 layers are needed to get to the top of the space figure. That's what I'm multiplying. So 40 centimeters squared is the area of the bottom layer, but since I need 4 layers to get to the top, it's going to be 40 centimeters squared times 4 centimeters. Well, centimeters squared times centimeters is centimeters cubed, hence why we have our units centimeters cubed. And I don't know if that's easy to see, so I'm going to go over it one more time. There we go, okay? And that's again why we have this whole cube thing and why volume is in cubes, because you basically do centimeters times centimeters times centimeters, or unit times unit times unit. Okay, so let's talk about finding the volume of a triangular prism. Same difference as any other prism. You find the area of the base and you multiply it by the height. So how do you find the area of a triangle? Well, that is 1/2 base times height, where the base of this triangle is 8 feet and the height of this triangle is 6 feet. Ta-da! So the area of the triangle itself, and 1/2 8 is 4, so 4 times 6 is 24. The area of that base is 24 feet squared, right, because it's area. But now that is just the first layer of my space figure, that layer right there. And I have 9 feet of layers, 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically what I'm going to do is I'm going to multiply the area of my base and multiply it by the height so that I get all of the layers needed to fill up my space figure, because I'm trying to figure out what's on the inside, okay? So there we go, times 9 feet, which is 216 feet cubed, because it was feet squared times feet. 3 feet means feet cubed. Okay, so again, just whenever you're looking at a prism, just find the area of the base and multiply it by the number of layers you would need, and the number of layers you'd need is the height. All right, you know, and it's the same thing for a cylinder that has a circular base as opposed to a prism with a circular base. Same thing. You're going to find the area of the base. Well, the base of a cylinder is a circle, so how do you find the area of a circle? Area of the base is area of a circle, and that would be pi r squared, where pi is 3.14 approximately, and radius is 11 feet. So 11 feet squared would be 121 times 3.14 is 379.94 feet squared, because again, that's the area of the base. Now I need to figure out how high it is. Well, that would be 5 feet, so I'm going to replace the height with 5 feet, and that's going to give me my final volume of 1,899.7 feet cubed, right? Because I have feet squared times feet, so 3 feet is feet, well, not actually 3 feet, but feet times feet times feet would be feet cubed. There we go. So the only thing is, though, is we needed to do it to the nearest cubic foot, which means it's going to round up to 1,900 feet cubed. All right, I'm done. Hope you guys had a good time with volume. Volume's so much more easier to do than surface area. Oh, poo-poo surface area. All right, bye.